This is a presentation of our thesis that is called Spatial Price Equilibrium in the World Natural Gas Market. So in 2019, in Canada, the price was $1 per million British thermal units. In Germany, it was 6 and Japan 10. The transportation cost to both of these destinations was $3. So someone could buy 1 million British thermal units of gas in Canada, transport it to Japan for $3 and sell it for 10 and make a profit of $6. Why is no one doing that? Isn't that strange? So the purpose of our thesis was to try to understand the world natural gas market using a theory which is called Spatial Price Equilibrium. We had another research question that was what the consequences would be of the cutoff of Nord Stream. Nord Stream is a pipeline that goes from Russia to Germany, and it was cut off during the autumn of 2022. And then another research question was, can Europe compensate this cut-off of Nord Stream with importing LNG instead? LNG is liquefied natural gas that one can ship in boats. So the theory here, the Spatial Price Equilibrium, says that the exporting country has a price. If you add the transport cost to that price, then that will equal the price in the importing country. But if the exporting country's price plus the transportation cost is larger than the price in the import country, then there will be no trade. This can be expressed in mathematical terms. And there are a lot of equations here, but we can look specifically at the yellow area, which is what we are interested in. This is the welfare. It's an economical term. And this term in the equation corresponds to the whole purple area here. And then one subtract the blue area corresponding to this term, and then the light blue area corresponding to this term. And not represented in the graph is the transportation costs. And then one try to maximize this function. The in data for the model is prices and quantity of gas, transportation costs, if it's the pipeline or LNG that is used as transportation method, and the distance for transport. Also the demand and supply elasticity is needed. So we store data from many different sources in a database, and then we generated, using programming code, GAMS code, so General Algebraic Modeling System code, which is a special program that can be used to solve this type of optimization problems. And we run 4 scenarios: the base, invasion, increased LNG, and peace scenario. So this would be corresponding to the world situation in 2019. This is the Russian invasion of Ukraine, and then the increased LNG shipping is something that we simulated, where we said that the fleet for shipping LNG is unlimited and everyone has all the LNG terminals that they need. And then the future peace scenario also, where everyone trades. After the invasion, the trade with Russia is limited to only certain countries, not including Europe then. This is not exactly true, but it's the way that our scenario was set up. There are many results that comes out from this. There are the output from GAMS itself, which is quite hard to read. So we wrote our own programs to generate graphs like this and tables. So looking at the situation in 2019, we can see that the large exporters, are Russia, Norway, Nigeria, Qatar, United States, for example, Trinidad and Tobago. And there are a lot of trade going on in the world. Japan is a big importer, as is Europe. According to the model in 2019, the most economical way, or the way we can optimize trade, is to do it like this instead. That's different from what we see in the real world, and this is a sign that the world market is not efficient, meaning that there are arbitrage possibilities. After the invasion, Russia no longer exports anything to the European countries, but instead China and Turkey starts to import even more. Europe compensate with as much gas as they can from Canada and from Qatar, and also some from Africa to these countries. If the shipping capacity of LNG is increased, then even more will be imported to Europe. Looking at the prices, we could take Germany, for example. So we have Germany here. The blue line here, or the blue bar, represents the price in 2019. After the invasion, according to the model, then the price is increased. But here in Russia, the price is actually decreased. When there are not so much demand for Russian gas anymore, then the prices reduces a little bit. If the LNG shipping capacity is increased to an unlimited amount, then we can see Germany here, that the price is reduced again to almost the same as it was from the beginning. Not quite the same, but almost. So, interpreting the results, the world market is not efficient. Invasion causes higher prices and reduced consumption in Europe, which was also seen in reality. Sanctions have diffuse effects. It's unclear how, if it's, having the intended effects, and looking at it from different perspective, it's unclear what is really achieved by stopping the trading. Increased LNG capacity will normalize the prices and consumption in Europe. I've seen in the recent news articles that, for example, Germany has opened a new LNG receiving terminal and terminal. But is it really a good idea to try to build up a new type of capacity for trading gas? And we have the climate crisis also, and the investment, in order to repay the costs, it takes a lot of time, and during that time probably we need to stop use gas anyway. So we suggest that we should really look into replacing gas with renewable energy instead. If you want to read more about our thesis that we wrote, then you can scan this barcode or visit this link. And there you can read the entire thesis and also look at some extra material that we have posted online.